Welcome to Learning with Philemon. In this video, we will be looking at how electrons are arranged around the nucleus of an atom. In the atomic structure video, we saw that atoms consist of neutrons and protons in the nucleus and electrons that orbit the nucleus. In the history of atomic structure video, we discussed Niels Bohr's contribution to the atomic model. Bohr realized that electrons exist in specific energy levels. In basic models like the one on the right, you see circles around the nucleus, representing these energy levels. This may lead to some misconceptions. The first is that electrons move around the nucleus on a two-dimensional ring. The second is that all the electrons in the same energy level are on the same ring. In reality, each energy level actually consists of different orbitals, of different three-dimensional shapes, which the electrons occupy. For Key Stage 3 level or GCSE chemistry, it is enough for us to understand that electrons occupy specific energy levels. See the orbitals video for more information. Each energy level can only contain a maximum number of electrons. The first energy level can contain 2 electrons. In this model, we see that a carbon-12 atom has 6 electrons. 2 electrons are in the first energy level, the lowest in energy and closest to the nucleus. The remaining 4 electrons must occupy the second energy level, higher in energy and further from the nucleus. This second energy level can contain a maximum of 8 electrons. Let's look at the example of sodium, Na. The atomic number of 11 tells us that sodium has 11 electrons. The first 2 electrons go in the first energy level. 8 electrons fill the second energy level. The remaining electron must occupy the third energy level. At Key Stage 3 and GCSE level, you're usually dealing with elements up to calcium, Ca, with 20 electrons. At this point, you can assume that the third energy level also only fits a maximum of 8 electrons, hence the asterisk. This is not technically true, but you will see this in later videos. If asked to draw these diagrams, remember to add electrons first to the lowest energy level. Continue adding until that energy level is filled and move on to the next level. Using this method, you cannot go wrong. The periodic table provides us a useful insight into electron configuration. The period an element is in, that is the row, tells us the highest energy level occupied. For example, you will find sodium in period 3. As you can see in the diagram, the last electron is in the third energy level. All elements in period 3 have the third energy level occupied by at least 1 electron. The energy levels are denoted by the symbol N. The group an element is in, that is the column, tells us the number of electrons in the highest energy level, also called the valence number. You find sodium in group 1. As you can see in the diagram, the last energy level has a single electron. All elements in group 1 have 1 electron in their highest energy level. In order to consolidate your learning, I would recommend using a periodic table to draw some of these electronic structure diagrams. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.